cheese. Alright, it's been a little while since I've been on here, so I figured I'd do a video on something realistic. So we were hunting this year, and my brother's UTV has a windshield, and it's an aftermarket windshield, and the way it fits, it's got these like C-shaped clamps that go around the tubes, and the windshield itself is decent, but the design for the windshield to be held in sucks bad. And there's no way to clamp the bottom of the windshield, so along the dash it just sits down on the dash with a rubber gasket. And so when we got done, so whenever we go on like logging roads, there's 4-inch minus or riprap or whatever they call it, and the windshield will like will vibrate really bad. And it also does it on really rough roads or if we're going really fast. And there are times where I'm holding the windshield because I don't want it to bust or vibrate like crazy. And it starts to even work. We put padding on the clips, and they even start to work off the clips from all the vibration. So at first we talked about just drilling L brackets or something really basic, and rightfully so. He doesn't want to put holes in his dash. I don't blame him. So then we were trying to think of like a way to tape it up or whatever. And so what I ended up doing was I have an Einscan, so it's one of the oldest versions of Einstar scanners. It's the IR scanner. It doesn't have blue line laser like they do now. It was like the first gen scanner. It works good. It's not a bad scanner. It's just that technology, just that entire field is making massive progress. And I'd love to have a blue line scanner, but I don't. So I ended up scanning his dash and part of the windshield, and I used Cloud Compare to align the scan the best way I could. So there's a crown in the dash, and I aligned the top of the crown aligned to the Z-axis. And if you know anything about Solidworks, it's Y up, so it looks funny when it's in Cloud Compare. I think it's tipped down, and then when you export out, it's Y up in Solidworks. So I used I can't remember, part of the windshield or the bottom of the dash to align it this direction. Anyways, in Cloud Compare, I did the best I could, and then brought the point cloud file into SolidWorks. And so we're going to switch over here in a little bit, and I'll show you guys on, it's my screen over here off camera. I'm going to show you guys the cloud, the point cloud, and we'll take a look at what I did to get from point cloud to first article. So the idea I have is what I've designed is like a cell phone holder, and we're going to get double-sided tape or Velcro, industrial Velcro or something, so that we can Velcro this cell phone holder to the windshield and then down to the dash, and then we don't have to put any holes in the dash, and it kind of does double duty. So we'll take a look at that. We'll go ahead and start with just the point cloud in SolidWorks, and then we'll step forward through what I did. I was gonna show you guys in process, but I spent, I don't know, 3 or 4 days screwing around with it and trying to ideate and whatnot. And then he got a iPad mini for Christmas, so we may end up actually putting a X mount, I can't remember what the manufacturer is, but off of the driver's side we may end up putting some type of mount so that we can mount an X mount to it and he can mount his iPad mini. But anyways, I tried to make something functional, so we'll get on with it. So we'll get over here to SolidWorks, and I'm going to do that one. The little guy in the corner. And so what we have here is we have an aligned point cloud. And like I said, I did that in Cloud Compare. And I'll show you the front view. So that's essentially the front. I actually think I aligned it to, yikes, this corner and this corner over here. And I think the crown is somewhere right in here. If I go to a side view, you'll be able to see that the windshield is skewed slightly. I didn't. So this right here should look more like, let's see, can I get it? Should look more like that. So this part right here should literally be, since it's a scanned face, should be like one line thick. And if you've ever used alignment software, it kind of sucks. I think, I don't know why I think this, but I think that I'd have to go back and do some research. I think that Fusion 360 is what a lot of people use. I don't know what the best way to align a scan is to an XY coordinate system. There are a number of probably very robust packages like Geomatic, or there's some other ones that aren't coming to mind right now, Geomatic Design X, and that may do a better job of aligning. So normally what I would use is a 3-2-1 alignment, or I would align it by 3 points. So this isn't perfect, but if I go back to the side view, not the front view, sorry. We'll go back to the side view. You can see that this essentially is straight across right here. And we'll look at the sketches here. So in SolidWorks, if you've got professional, you can get this thing. Let's see. Do I have it turned on? Add-ins. Scan to 3D. And I'm not going to go into it, but essentially what you can do is you can insert. Where is Scan to 3D at? Tools. Scan to 3D. You can do a curve wizard. I could have also done a surfacing wizard, I found out later, but I just use the curve wizard, which generates these splines. And so this is actually a generated spline right here. When you do the scan to 3D, you can use a plane as a sectioning tool, and it will it'll fit a spline to the, excuse me, I ate sardines. It'll fit the spline to your point cloud, and basically you can give it a tolerance of how many points away from the median or the midline that it references. So I always set mine down around 0.1, so 10 thousandths. Is that right? 10, 100,000. Yeah, 10 thousandths wide. And I think what it does is it takes all the points in 10 thousandths and projects them into the plane that crosses. At least that's what I imagine it does. So I tried to put one right at the crown, and these that's an actual spline that's been pushed into a sketch, 3D sketch. And then you can see this one here is also a sketch across the top edge of that face. And you can see right in here there's some type of feature that dips back up. And I'm more or less trying to create near surfaces, right? Again, this isn't Geomatic Design X. I'm not going to get an actual surface. Now, I did find out later I could have generated surfaces So there's a couple of caveats here. If you're doing this, when you create a sketch, the first sketch you create that you put dimensions in, when you put your first dimension in and it scales, you undo that. So let's say you go to dimension something and it says it's, I'm going to say it's 15.5623, right? It's just over 15 and a half. And let's say you want to constrain whatever it is down to 15. It will scale the whole thing. And I believe it scales the point cloud as well. So what you would do is you'd undo that. So you'd Control Z right after that happens. And then I believe you can edit that dimension without it scaling. And there's some other things that you can do that will move your point cloud down the feature tree. And you want the point cloud to stay at the top. So I don't know what causes that behavior. I forget what I did. I did something, interacted with the point cloud, and SolidWorks moved it to the bottom of the tree. So we're going to move on. I'm sorry that was so long. So then I generated a plane, and the plane was right on top of that sketch. Did I even need that? That plane may not be used. It says it is. Okay, so I generated a boundary surface. All right, so you can see right here where it's not quite matching. So my surface is high. I generated a boundary surface. So what I did, this is a straight line that intersects. In fact, I'm going to turn the point cloud off. By the way, you can only turn the point cloud off. Notice how there's no way over here to do it. Nothing to click, right? So the only way you can turn the point cloud off is to hide it in the right click menu. So again, I would consider that a flaw. Probably has something to do with 2018. With the way SolidWorks is slow about things, I'd be shocked if it was fixed in 2025, but maybe it is. So we're going to actually turn off these two 3D generated sketches from the cross section, and we're going to have a look at what actually generated this surface. So that's literally a straight line, and this is a curve. And so it generated this face, right? It's a symmetric face across this line here. I probably could have lofted it. There's a couple of ways I could have done it. I chose boundary surface. So then I'm going to turn the point cloud back on so you can see what I'm doing. So you can see the surface is high here, but I'm generating something that's going to be using double-sided tape. So I have a certain amount of thickness that I can sort of fudge factor. Because it turns out the windshield is not actually the face of the dash. I'm not used to doing this. So the face of the dash, actually I can point to the video here. That makes more sense for you guys. The face of the dash there, the face isn't planar to the windshield. So the windshield actually runs off that way. This side over here being further away as compared to this face across here. So and I only found that out at the end. Can I show you guys? I'll try to show you. So let's see, does that work on the... Oh, it actually does. Okay, good deal. I'm glad that works. Escape. Let's get back to that. So there's my first surface. This surface here would be for the windshield. This is the one, you can actually see it right there. So I just generated another line off this 3D sketch right here. So this sketch came from, that right there is from the scan data. What you can see in this image in all reality, where this comes from, actually, see how it's this surface is out towards us. So this area right here is towards the screen. This area over here is actually on the on that side of the windshield. And um, what it is the scan itself is tilted away like this. So if you watch my cursor, this area here is actually away, meaning I have the scan tilted slightly one direction. I wasn't able to get it perfectly lined up. And that's where I don't like. I wish there was a way, there was some alignment software where you could pick a face, and so I could align it in one direction and then lock that axis. And you can kind of do that in Cloud Compare, but I'm not an expert in Cloud Compare, so that's part of the problem here, but we'll get back to this. So windshield, right? Two surfaces. I've got these are all going to be to construct that front face there. So you'll see here in just a second. So you can see these two sketches here. And if I look at it from this direction, you can see that it's curved right here. This has got a significant amount of curve across this face. So, did I combine? Is one of these combined? Sketch 7. 5. Where did 5 come from? So 5, sketch 5 in the middle there is generated from 3D sketch number 4 up here. So that's my midpoint. So the dash doesn't have symmetry. That face there is actually canted, I believe. So I'm pretty sure it is. I don't think it has real symmetry across this point right here. So let's get back to it, man. So surface loft, and then I wanted to get this loft out to the edge here so it would cut well. So I surface extended it right through the ends right there. So you can see we have 3 surfaces so far, kind of the front edge of the dash, top, and then windshield, which is a plane. So let's see, what else do we got here? Then I generated some sides. These literally were artwork. So if I go into the sketch itself and we have a look at it, let's get you guys back here. So you can see that this is just an arc. It has a 10-inch radius, and I just generated some numbers to get the sides. So if this is my origin, it's 2 inches up, 4 inches down. So I would call this arc, and it's 6.5 inches here and 6 here. So in this particular case, this is just a way to get these kind of Darth Vader edges that that kind of encapsulate the surfaces. So we'll go ahead and exit out of there. So you can see those surfaces go through both sides. They go through all the surfaces. And if you're not used to working with surfaces, this is going to sound like gobbledygook to you somewhat. So then I did a surface trim, and I trimmed off everything. Why is it not showing? What's going on here? In fact, I'm going to get rid of the point cloud at this point. So, and we're going to get rid of that. And we're going to get rid of, what else is showing? This, and that. Okay, so the first trim, let's undo it. You can see I just trimmed these two together. So this surface and this surface are now joined. And there's all this overhanging geometry that you can just ignore, like this piece here. But the next offset, so what the reason for the offset, so you can see what I did here. Let's get it so you guys can see it carefully. The reason I did that offset, think of that, I'm going, yeah, there we go. I'm going outward. Think of it like clearance between the dash where the double-sided tape's going to go. So surface offset for the tape. And then I'm going to actually hide this inner surface because I don't need it anymore. I'm just disregarding it. There's all this extra patchwork here that I don't care about. It's going to go away and get trimmed. So my next trim trims off everything inside the two Darth Vader wings. And these basically are acting as trim. And I trim now this surface, that all three of these surfaces are joined together by the trim function. Then I'm going to extrude something. What am I extruding here? Okay, so this extrude is actually, I'm starting to now form, we'll go into a see-through view here, and we'll go to a right side view. So this surface extrude here, why did it do that? Surface extrude 3. This surface extrude is forming the top of my tray. So if we have a look at the sketch, all this is meant to do is make the top edge of the tray. You can kind of see what it formed. So we'll go back to this view, and you can see that I basically just put a front. This is a separate surface that's on the front here now. I'm going to trim off so in this trim operation, I trimmed everything out. So if we have a look at what I trimmed, you can see all the stuff that's transparent is what I trimmed. So I did a mutual trim. This is all my surfaces that were included in the trim command. And then these are all the pieces that were trimmed out. And they're gonna be that one and these two back pieces and this piece right here and these little wings up front. And I ended up being able to, did I get a solid out of this? I can't remember. Let's see, nope, I'm still got two surfaces. So that's because the bottom isn't, I've still got an open bottom right here. So you can see that that's open. So I have a mostly watertight model. I don't have a complete watertight model just yet. So then I did a surface extrude, which was just an arc across the bottom here, and coincidentally, it matches up to. You can see in the, it's hard to see it, but let me actually turn these off for a second. So you can see this shelf right here, this indent. And you can see that this actually, the radio right here, some charging buttons, and it's inset. So I made the trim right across the middle of this face right here. So we'll turn these two back on, and we'll get rid of the point cloud, hide. And then I'm going to use one more trim, and I think I'm getting a solid out of this. I am. So we now have a solid body. This body can be ignored. In fact, that should be deleted. So on this surface trim, there was an option to create a solid right here. Sorry, guys. I should have had this open. So you can see right here, create a solid is here. And that's what I did. So you can see that this was just to trim off that face along that edge that I was hopefully showing you guys. Gosh. It's hard to remember to switch back and forth between the different views when you don't do this a lot. So then there's a chamfer right here. The reason for the chamfer is that clears the rubber on the windshield. Again, we're going to turn the point cloud back on. And if I section this, you can actually see that right there it barely is going to touch the rubber. But if I roll this back, you can see the idea is that chamfer is meant to clear the windshield rubber, and this little bump out right here is the rubber protector that goes around the windshield. So anyways, we're going to turn off the point cloud again. And then at this point we have this solid, and so at this point we can start treating it like a solid, something you're probably all familiar with. So I did a cut extrude here from the side view, so I'd get consistent wall thickness. We'll actually have a look at it from the side. So you can see it's thicker down here and thinner up here, but on the front here it's consistent wall thickness. And then if I go from the front view, I have, how would I show that to you guys here? You can see when I get back here, I have a thin point right here. So my thinnest point is 1/4 inch. And I believe the walls are 1/4 too, or maybe it's 3/8. You know, this is all 3D printed plastic, so I don't know if this is going to hold up or not, but I figured it was worth talking about because some of you might want something like this. And then obviously you do all your filleting if you can help it at the last. So I filleted the inner pocket, inner wall. What did I do next? I filleted the sides. Order matters on these fillets, or they'll roll around. Like at one point I had filleting rolling around down here, and that would actually go, it would have undercut where it touches the dash. You want it to have a square sharp edge, so there's no undercut at the dash. So filleted these two faces here and filleted this back edge here. And then let's see what I do after that. What's that fillet? I think that fillet runs around the top, but it doesn't. I didn't fill it back here where it's close to the windshield. So let's see. Yep. So filleted that edge. And then what's one of my last features? Let's see. What's this fillet? Oh, this fillet is where the breakover for the dash is right there underneath. And then what's fillet 7? Fillet 7 is to soften that front edge. So one of the things I thought about doing is I actually thought about making this stick out a little more, and essentially, let's see if I can. So what I thought about doing was making a pocket right here. And the reason for that is you'd be able to have maybe weep holes that came out the corners. So for water, you'd have water shedding or dripping here. I also imagined that you might be able to stand a phone up if you made this tall enough. You might be able to stand the phone up vertically, so your phone would be like this. I don't actually think that you guys like my mouse skills there. I don't think that's going to work. I don't think it would stand up vertically. So this might be helpful to to, let's see. Might be helpful to tell you how wide this is. So I'm pretty sure this is 12 inches wide. Let's see. It was the Darth Vader. Right. Where is it? 6. Yeah, so 6 inches to center. So this thing is this thing is 12 inches wide total. Let's see, back to 6. So this is what I have right now. I'm thinking about adding sort of on this side over here. I'm thinking about adding kind of this was for that X mount. Some type of surface that goes like this. You know, something that comes off. In this area. And the reason for that, man, I suck at this. The reason for that is that he wants to mount his iPad mini on this thing. So it's probably going to get some more development. I think I'll probably print a first one, even though it's going to take a bunch of filament, just to see how well this thing works. This is, here we go. So this top face here is 1.5 inches, and then the cut extrude is 1/4 inch deep. So I think that's 1.25 inches. Let's check. From here to here is 1.25 inches. So, I'm sorry I suck at this. I'm not a very good OBSer. But this sort of concludes the shelf. Actually, what I'll do real quick, we'll go back to here and we'll take a look at this with the point cloud on. So you can see how it fits the dash. Pretty simple. The dash steps down right in this area. So it's going to have more space there. If we do a section real quick and look at this thing from the side, and we'll start over here. And we'll go with a direct side view. You can see it doesn't perfectly match. I have to tilt it a little bit. It doesn't perfectly match the point cloud. Obviously, I could have spent more time aligning the point cloud. Anyways, you can see how close it. You can kind of see how close it follows the top of the dash. It's pretty close. It's gonna work. So it's not super pretty. It's real basic. I'm not an industrial designer. I could have made it a lot swoopier if I would have spent more time on it, but I haven't quite figured out what I want to do with it yet. I know I gotta have drain holes because water does get inside the cab area when we're driving around in the rain. I think there might be a case for some hooks, some robust hooks on the front for possibly keychains or walkie-talkies. So anyways, that concludes the show, folks. So hope you learned something. I hope this helps somebody out there. 3D scanning, especially when you don't have any flat surfaces to reference, is new to me and kind of a pain in the butt. So that's how I did it on this one. We'll see how I do it on the next one. As always, I hope this helps somebody, and I'll talk to you guys later.